Good afternoon, everyone. Thank you for coming along to our webinar on the fifth facade. I'm very pleased to introduce the panel that we've got today. And we're here. I'm Pete. I'm the deputy editor of Inside Housing magazine. I've written a lot about fire safety over the last few years. The topic we're here to talk about today is the fifth facade, or in more common parlance, the roof. It's something that we don't always talk about very much in fire safety, but that doesn't mean it's something we shouldn't be talking about. Anyone who knows about safety and about planning for prevention of major incidents knows that it's blind spots where we are most vulnerable. And sometimes this can be one of those. So thank you for coming, and I hope we're going to learn a lot today about this important area. I'm joined, I'll introduce each speaker as we go through, but we're very lucky to be joined by Mark Chubb, who's Technical Director at the Institute of Fire Engineers, Steve Sinclair and David Perez from the architects firm Fourth Space, Paul Barrett from Rockwall, and Laura Smith from Gen 2 Group. We're going to be hearing from each speaker in turn for about 6 or 7 minutes, and then we're going to have time for Q&A. So please do put questions in the chat box on the app, and we will get those to our panelists after everyone's had a chance to speak. The event is going to be on demand on our website next week, so please do share it with colleagues if it's useful, and watch it back if you want to recap on what people have said. You can also download the speakers' slides as they speak via the platform that you're watching this on. So without further ado, because we have a lot of speakers who I'm keen to hear from, I'm going to introduce our first panelist, which is Mark Chubb, who is the Technical Director of the Institute of Fire Engineers. He's joining us all the way from Seattle. Over a 40-year career, Mark Chubb has held senior technical and executive positions in fire services in New Zealand and the United States. He retired from the fire service in 2015 and accepted a role leading the remediation monitoring program of the Alliance for Bangladesh Worker Safety in Dakar. He currently serves as a principal with Code Unlimited in Seattle and oversees the firm's fire protection practice. And he also serves at the faculty of the John Jay College of Criminal Justice at City University in New York. Mark is going to give us an overview of the risk of fire in a roof area and the engineering principles to consider, particularly with modern innovations such as the installation of solar panels, green roofs, and rooftop gardens. Just before I hand over to Mark, I just have remembered I'm going to be doing a poll, which I forgot to introduce in my opening remarks, but I'll do it after Mark's spoken now because I've just introduced him. So Mark, over to you.
Thanks, Pete. So to preface what's going to happen during the rest of the presentations, I was asked to just give you an overview of what's changed and why are we concerned about it from a fire safety standpoint. Years ago, when I first started, which, as Pete reminded me, is quite a long time ago, we didn't ask roofs to do a whole lot more than keep the weather out of the building. But these days, there's a lot more going on the roof than just the roof covering itself. So, I think a lot of people over the years have looked up at the roof and said, why let all that space go to waste, especially all that lovely space in a dense urban environment where I can access the natural world. I can reconnect with what's outside. So we're now letting roofs become a much more active space in buildings, and they've become a attractive place for tenant amenities such as entertaining spaces, gathering places, cooking and dining facilities, relaxation and recreation facilities. And let's not forget our furry companions, pet care spaces, exercise spaces for our companion animals. We've always had some building services up there, but the types of building services that we're expecting to put on roofs has changed a lot over the years. As you can see in the illustration here, long ago, this was a place where we might put a water storage tank, maybe a chiller, but we really have a lot more going on now in terms of building services. And as we've started to try to achieve net zero in the built environment, we've certainly seen the roof as a great place to harvest solar energy and convert it to electricity. So the advent of solar panels has certainly changed the rooftop environment. It's taken up a lot more acreage, if you will. And of course, we've all kind of fallen in love with those little devices, those computers we carry around in our pocket called cell phones that connect us to the world. And being able to provide coverage means providing line of sight access to the telecommunications equipment. So we're seeing a lot more cellular installations on roofs. And with that comes not only antennas and transmitters, but also storage batteries to ensure the continuity of service during power outages. And finally, we've seen the roofs, especially in urban areas, as a way to reconnect people with the natural environment. And that has a couple of benefits. One is it's a way to reduce uh, the contribution of the building to the carbon footprint, but it's also a great way of managing rainfall, collecting rain, and achieving other net zero goals aside from net zero energy. So we're seeing an increasing use of roofs as vegetative spaces, not just because they're biophilic in nature, they provide a place for people to reconnect with nature, but they also provide some really practical benefits for buildings in terms of our attempt to achieve net zero. Next slide. So what's all this mean? Well, years ago, we developed fire safety requirements for roofs, beginning right around the 1970s. Some of the earliest tests were developed to assess the ignitability of the roof under certain conditions. We were very concerned at that time with the prospect of igniting the roof due to burning brands from adjacent wildfires. And brands are simply burning embers that are carried aloft on the thermal column and then distributed by the cooling expansion of that column on other buildings. So the burning brand test attempted to replicate those conditions by placing small burning embers or small wood cribs on the surface of a roof assembly and evaluate whether or not a subsequent ignition occurred. To assess roofs under conditions that were more realistic to proximate wildfires rather than distant wildfires, we added the element of wind. Wind has sort of a combined effect. It helps some of the larger brands keep burning, but it also cools the brands and cools the air. So what we were looking for was how the distortion in the flame and the prolonged burning of the ember might affect the ignitability of the roof. We decided to enhance that test. Again, wildfires have become more frequent, more severe, and more proximate to buildings. So we added radiant heat to that test. The radiant heat has a twofold effect. One is it enhances the burning of the brand, but it also preheats the other elements of the roof surface, making them more vulnerable to ignition, which also accelerates their flame spread. And of most concern to many people who are probably attending this is the addition of a fourth test, which combines several of these elements and is really quite challenging. So the new ENV 1187 classifies roofs according to these four test protocols, which evaluate a number of conditions. The flame spread across the roof surface, which begins with ignitability, the flame spread within the roof cavity. So we're not just concerned with the roof covering material itself, but the insulation, the vapor barrier, the decking, the entire roof assembly. We're looking at whether or not the fire penetrates from the outside to the inside. And then we're also looking at whether or not burning droplets form and then spread the fire either internally or to other elements or other parts of the roof assembly. So these tests are really quite rigorous. Their scope and applicability depends on the type of construction, the building's use, and the regulatory regime you're operating under. Just to reassure folks, ENV 1187 exists in many different national standards around the world in under different labels, but the same test method is applied here in the United States as well as Australasia. And although this is a European test method, the methodology itself, the underlying logic of this test, is widely recognized in other countries. As far as roof fires, how common are they? Well, roof fires themselves aren't all that common, but roofs are commonly exposed to fires internally and involving other equipment. And I think as we see the roof become a much more active space in buildings, we should expect to see the incidents and possibly the consequence of fires increase accordingly to the extent that it's going to match the likelihood and consequence of fires that occur in other spaces the building used for similar uses. About the only advantage the outside has over the inside is that when fires and smoke develop from fires, they're going to spread to the outside rather than spread to other occupants. They're going to be less likely to block escape routes and cause deaths and injuries, but they have the prospect of causing quite considerable damage to the building, and in many cases will disable the building's reoccupation and reuse. So I'll end it there to keep things moving, but thanks again, Pete, for the opportunity to talk about the fire safety aspects of this, and looking forward to hearing the other presenters.
Thank you very much, Mark. That's a very, very informative presentation. I will now introduce the poll, which I was supposed to do at the start. So we're going to ask, does your housing association or the social housing provider you work for own a property that utilizes the roof area? Perhaps it was helpful to have this after Mark's presentation to give us some thought about all the ways in which it might be utilized. So I'm going to gather the poll results now, so you should see it appearing on your screen. And I might leave that open, and I will move on to our next speakers, who are Steve Sinclair and David Perez, both from Fourth Space Architects. Steve Sinclair is a co-founder and director of Fourth Space and has practiced architecture in London for over 25 years. He's a fully chartered architect with an MSc from the London School of Economics after architectural training at the Mackintosh School of Architecture and the Bartlett School. He previously worked at Morphosis, Ron Arad Associates, FAT, and left Harper Mackay in 2004 to set up Fourth Space. He will be speaking alongside David about the design process of several case studies, including a low rise in respect to fire compartmentation through roofs and a building above 18 meters with different criteria and challenges. So a lot for them to pack into their 7 minutes, and I'll hand over to them now. Thank you, guys.
Thanks, Peter. Hi, I'm Steve. It was maybe a few years ago during COVID that when we picked up on a kind of change of clientele, we were quite encouraged to sort of see clients beginning to engage with the fire safety in buildings, but not just fire safety in respect to in keeping with building regulations. It's like being more robust, holistic overall, and the roof is often part of that discussion, mainly because involvement with Hounslow's 5,000 new homes pledge, where we were doing lots of infill sites for housing association, ranged from about 2 units to about 20 units, and there was about 16, 17 sites. Quite often, because of planning policy, as Mark was alluding to, you end up having to sort of utilize the proposed roof space for outdoor amenity or private amenity, and sometimes shared amenity, because these infill sites were quite contained and quite awkward sites with little outdoor space. So in a way, we had already been talking about how that roof space becomes like a facade. It becomes like a kind of, it becomes thickened. It thickens with insulation, but potentially other uses. So you're dealing with trying to get a kind of robustness of that roof technically. And during that process, we also had a building on site, which was a mixture of tenures. And that was in Epsom. And what we had found was that simplifying some of the details through compartmentation, fill cavities, and so on, and checking it through with all the building warranty people, building control inspectors, and fire engineers, developing fairly low tech, fairly effective, following through, fill cavity, through into the roof space, getting that problem sorted. So once we had kind of figured out just getting that robustness, it kind of freed us up to sort of do things a little bit more imaginative with rooftop amenity space on the other project we were doing at planning stage. This led on to and Mark's right, it's becoming more and more common how we increase the use of roofs a project that we recently got planning and is going on site this year has got a range of roof spaces, and we are having to deal with not just the making sure that we've got the right use of roof, the right detail, the right thermal performance, the right fire performance, and inspective spread of fire. But we're often having to deal with attenuation at source as well. So you're dealing with increasing amount of blue roof technologies, green roof technologies, balancing up where the renewables are going to go, and also making the space truly active and usable. And in that regard, that becomes another kind of challenge where you have to take that roof space as a new facade. And I think the title of this talk is important to consider. So there's a whole analysis we did at planning stage, really looking at the seriousness and the appropriateness of what can happen on each of these stepped roofs as it went up and around the building. Now, the one that I think is interesting and we've been involved with recently is this aspect of adaptive reuse of existing buildings, where buildings are tired, they might have non-combustible materials, they might have problems with the way they're laid out and they're not up to date with current fire regulations, and we've got the policies about air rights, permitted development rights, and so on. These are difficult to as architects with particular types of clients to deal with, but I find that we're fortunate with a client at the moment who has really engaged with the adaptive reuse of existing housing and is currently active. We're doing one project at planning stage where we're involving fire engineers and M&E engineers and a whole design team at quite a detailed stage before we're getting even close to submission to make sure that what's being added onto the roof, how existing roofs are being dealt with, and to consider the existing context as well in terms of fire spread. And I'll just sort of leave you with a few things, more technical things for David to talk about on another job we're doing where we didn't get involved in planning, and the building was we were involved to deal with the post-planning stages. The building wasn't designed appropriately for the current fire regs, and we've had to sort of redesign it to sort of allow for a realistic roof space amenity, which goes back to my first point. We've got limited space, and the space on the roof became the only area for shared amenity. So that's all part of planning policy, but then things are getting through in planning that haven't really been detailed as such. And that kind of challenge is one that we're getting more used to overcoming, and certainly we certainly deal with it all the way through pre-planning stages. So David, can maybe you explain that situation we had in respect to fire safety and the roof build-up on that project?
Yeah, as Steve was saying, we inherited the project from planning stage, and it was a big challenge to convert the current approved rooftop into something that incorporated all the necessary amenity spaces that the project required, which was also required for planning, which was also a bit contradictory. So you made that happen by changing the roof build-up into different areas, and including a play area space and some of these blue roof situations, and considering at the same time working close with the fire engineer and changing the course and incorporating this fire strategy. That was, as I said, very, very challenging. But this is the challenges that we're facing nowadays when we have these projects that we inherited from planning. And as Steve was saying before, this hasn't been thought properly at the early stages of the project. And in tight spaces, this is what we need to think about. This is what we're facing in construction phase.
I think just to add to that, with that particular one, you immediately sort of see things like, right, we need to add an extra core here for means of escape. We need to really bolster the overall build-up. And with that, you're having to sort of engage with the planning authority, engage with building regulations and at the client level, just to make sure that you can unlock some of these problems as a kind of collective attempt, basically. So you need to sort of work together quite closely. And I think if I'm just going to sum up before we move on, I think this is an interesting area, and I think the increasing amount of retrofit and adaptive reuse, that particular context, this kind of discussion is quite important. Thank you.
Thank you, folks. I'm now going to attempt to publish these poll results. All right. Hopefully you guys can see that. I can't, but never mind. We will move swiftly on to our next speaker, who is Paul Barrett, Head of Product Management at Rockwool. As Head of Product Management at Rockwool, Paul Barrett is at the forefront of product innovation across the company's full portfolio. Leading an ongoing program of independent testing and certification, he is responsible for maintaining the highest quality levels and compliance with the latest standards. An authoritative commentator on insulation-related topics, Mr. Barrett actively participates in industry discussion and education regarding the importance of non-combustibility. Paul is going to talk to us about the UK regulation and what the sector needs to consider in this area. So without further ado, over to you, Paul.
Thank you, Peter. I think some of the subject matter I've got within my my slides have already been covered off quite well by Mark, and it's been interesting to hear the other guys. But at Rockwool, we certainly feel that there's a lot been said around the combustibility of insulation products used in facades for a number of years now, obviously following Grenfell. But we strongly feel that the roof is an area of the building which is largely overlooked and often responsible for the development of fire. If we can move on to the next slide. I mean, there are a number of common sources of ignition. Sorry, if we can move on to the next slide again. In respect to the roof, there are arson, which we can't do much about really, but makes up 50% of all fires. Hot works is still quite common within the UK. We're still using torches and roof torches and applying bitumen to what is often combustible substrates. Localized spreading, which happens in another part of the building, but makes its way to the roof, and then the roof acting as a means for the fire to spread further. And more commonly, roof-mounted equipment. Mark touched on solar panels, and that's certainly an area that where we see more fires, and not just in the UK but across Europe. I think in 2012 in Italy alone there were 600 fires attributed to PV arrays. So a number of different sources in relation to fire and fires that can occur within the roof system. If we can move on to in fact, we can skip the next slide and we'll go straight into the classification standards and the regulatory compliance. If you can move on to the next slide. Mark's already covered quite succinctly the test standard in relation to 1187. In relation to that, we have the classification standard, which is BSEN 13501, and this uses data from the external fire exposure to roof test 1187, which Mark referred to earlier. Within the classifications, they range from B-roof T4 to F-roof T4, with B-roof T4 indicating the sort of highest level of performance. The T4, again, Mark mentioned earlier that there are 4 tests as part of that standard, and this particular standard can be used to assess how a roof behaves when exposed to an external fire. and it uses the test involves burning brands, winds, and radiant heat. But it's quite important to understand the level of information they provide and where this is relevant, and also what they do and what this provides us and what it does not provide us. If you can move on to the next slide. Because there are some do's and don'ts with this particular standard. It does test for surface spread of flame from an external fire. It does look at the fire penetration through the membrane, and it does look at things like droplets and charring, and pretty much gets achieved by virtually all commonly used roof build-ups. I don't see it as a particularly onerous a test. Mark may disagree, but it does seem to be quite easily achieved. What it doesn't do, it doesn't subject the roof to a fully developed fire. It doesn't consider fire penetrating from the underside of the roof, and it doesn't offer any level of fire resistance rating. And very importantly, it doesn't define the combustibility of a roof system or its component parts. We often see, as a manufacturer, a lot of confusion with the BROOF T4 standard in the lettering, and I think the B's often getting confused with the reaction to fire performance of individual components. So you could have a product within that system which has a Euroclass classification of F, but still within a system that achieves BROOF T4, and I think that's quite important to understand. In terms of regulatory guidance and where particular attention is required, roofs can be used as a means of escape, and there are some requirements there in respect to fire resistance ratings of up to 30 minutes. And the roof can be used as a floor, where it's an upstand, balcony, or terraced area. There are standards in BS 8579 now with information there, and also quite importantly across the compartment wall, where there are requirements for a minimum level of reaction to fire performance in relation to the materials that are used there. But there are also areas where there is lacking regulation. It's clear within the building regulations, the statutory requirement for both roofs and walls are pretty much the same. The only difference is actually the word roof. So the roof of the building shall adequately resist the spread of fire over the roof and from one building to another. But whilst it's virtually the same, there's far less guidance for the use of non-combustible materials within a roof. And modern roof constructions and the function of flat roof are rapidly changing. The multifunctional roofs for socializing, again, the other presenters have already touched on this, but as a manufacturer, we're also seeing this, terraces, gardens, restaurants, bars, farming, gyms, pools, and cafes. We're seeing a lot more usage in the modern roof system. And that brings us to maybe some of the other issues, particularly I think the accountability that there are now for architects, and maybe some of the pressures that are put on them now in respect to the Building Safety Act, and areas I feel where there's more clarity needed, and that solar panels is particularly prevalent for me as one of those areas. There are currently very few. Neither in the approved document B or in BS 8579 any guidance for the use of solar PV panels on flat roofs. However, the insurance industry recognises that there are some clear risks in relation to this. PVs at the risk of electrical arcing, mechanical components that degrade over time, panels that trap and collect radiate heat towards materials, increasing the roof temperature, which if you then have combustible materials below can become a problem. And then improper positioning of rooftop PV arrays, which make roof access and system inspections quite difficult. That's the next slide. What we're seeing in terms of the forecasting is definitely a move in the future towards more and more use of PV arrays within buildings. It's clear in the UK, as with the rest of Europe, that the market for solar energy is growing rapidly. The European Commission reports that the cost of solar power has decreased by 82% over the last decade, making it the most competitive source of electricity in many parts of the EU. The commercial rooftop market for solar PV was up 135% during the first half of 2022. In 2023 and beyond, commercial rooftop installations are expected to grow 30% year on year. And in the UK, Solar Energy UK forecasts 40 gigawatts of solar capacity by 2030. And to put that into context, we're currently at around 14.6 gigawatts. So I think we would all agree that we need to become more energy independent, but I think it's important that we're not setting the foundations for future fire safety issues. And we already have seen fires in the UK. More recently, the fire in Bristol at the We the Curious Museum, which was attributed to the solar PV array, where birds had actually pecked through the electrical wires and caused arcing. And this event sort of also highlights the wider impact of fire, because although the fire service was able to arrive and manage the fire pretty quickly, the amount of water needed to extinguish the fire from the roof inevitably led to seepage and water damage through the building, which the fire didn't actually reach. So largely the building was compromised, by the amount of water. So with these incidents in mind and forecast of significant growth in use of solar panel, perhaps now is the right time for a deeper revision of the standards and a review of the risks that these pose. And I think that's it from me. Thank you.
Terrific. Thank you, Paul. So we're now moving on to our final speaker, who is Laura Smith, the Strategic Fire Safety Manager at Gen2 Group. Laura holds the position of Strategic Fire Safety Manager at Gen2, based in Sunderland. The group has 30,000 homes in its current portfolio, and her role is integral to the strategic management of their high, medium, and low-rise blocks of flats. Ms. Smith has implemented the fire safety risk management system for the group and is now ensuring Gen2 are prepared for the coming changes due to the Building Safety Act. She's had a varied career working within the NHS, managing fire safety for 3 hospital sites, and previously as a senior fire safety inspector in Hertfordshire's Fire and Rescue Service. So Laura brings a lot of experience and practical knowledge to the table, and she is going to talk to us about a Gen2 building case study and how the Housing Association has engaged tenants about fire safety in the roof area. So Laura, over to you.
Thanks, Peter. So I'm sure everyone will be well aware that from April 2023, all accountable persons for high-risk buildings have been required to register our buildings, which includes information on the roof space and what materials are there. If we've got a new build, that information will be readily available to us and makes that process a lot simpler. But like the majority of everyone, our high-rise buildings are not that new. They date back to the 1960s, and information on them is scarce, which I'm sure is not unknown within our industry. On top of that, a lot of our high-rise buildings have had many refurbishment works, including adding additional structures to the top of them and upgrading the insulation to improve energy efficiencies within the buildings. So how do we manage that? Well, in Gen2, what we try to do is we try to find competent contractors, which are very scarce within the UK today. We've looked at ones that can work on access within the high-rise buildings, as well as looking at who can assess the materials on those. The PAS 9980 has helped develop a methodology for external walls, but it doesn't include the assessment of the roof spaces. We recognise this, and when we appointed the contractors, we made sure we spent enough time on our scope to make sure we got it right so that the assessment of the roof took place at the same time. Lessons that we learned from that was ensuring that we have a competent contractor who is able to do it and work on high-rise, and make sure that the contractor records your percentage areas. So within the high-risk building registration, you need to record the percentage areas for your external walls along with the percentages of the roof space and the materials used within those. So that would just help you comply with the Building Safety Act. Other modern refurbishments, if you could go back a slide, sorry. Other modern refurbishments include, that's completely from me, making sure that we've refurbished our buildings. Now, we've tried to use non-combustible products for our refurbishments. However, the long-term efficiency in waterproofing is not known at this moment in time. And we have had experience with our refurbishment works where we're now seeing an increase in water damage and damp on mould, which everyone in the housing sector will agree is another risk that is difficult to manage. Again, with our roof spaces, like Mark and Paul have all touched on, they're great for housing, plant and machinery. But not all of our equipment is under our control. We're seeing an increase in rental space on our rooftops from other organisations that want to put on telecommunication devices and transmitters. Understanding the risk that these pose is critical for our building safety cases and involves us having a cooperated approach with the other accountable persons to make sure that our building safety case fully accounts the risks that are posed on our rooftop spaces. On top of that, managing our residents. So in our case that we're going to run through, next slide please, which is River Quarter, which is based in our Sunderland City Centre. We've removed a lot of the external walling and replaced the rooftop products. During this, we had to manage our contractors to ensure that the hot works that they did didn't pose a risk to the products that we were using. We made sure we were putting the right products in place. We also ensured that we had successful tenant engagement. To do that, we liaised with our residents and made sure they were aware of the risks that the rooftops provide. If you could move on to the next slide. So you can see in the picture present there, we've got a lot of rooftop space, which is used as gardens. So we made sure they were aware of what materials can be put up there and what can't. We're seeing an increase in people putting up timber cladding panels to make it look like a prettier space, but also not very fire safe. We've also seen people trying to put motorbikes on the top of our roofs, which obviously is very difficult to manage, but making our residents aware of these risks and making sure we fully engage with them and informing them of how that's a risk to the building has been vital in that. Tenant engagement is a critical part of building safety, and it should be the tenants helping to drive safety forward within the buildings that makes our building safe. At Gen 2, we're very fortunate as we've got a fantastic janitorial team and a great high-rise building safety team in our housing teams. They're critical for making sure that our buildings are safe. And what we've also achieved is through those teams is stronger communication with our tenants. Through that, we've been able to do pre-start meetings, which are face-to-face in consultation with the tenants. We have liaison officers dedicated within the buildings during the works, and also we have weekly drop-ins. Where residents are not able to attend these sessions, we've had prominent notice boards in our entrance lobbies, while also sticking with the more traditional methods of letter drops and door knocking. Lessons learned from our tenant engagement so far is utilising our tenant data to target comms through either text, email or intercom messages. Having a full understanding of your tenants within your building and the demographic will just further focus your tenant engagement, and it should be a key priority. In one of our buildings, we take a more face-to-face approach. However, in others, we may take a more traditional approach of letter drops or SMS messages. So our key message to everybody is, whatever the message is you're trying to provide to your tenants, it should be approached on a building-by-building basis, and this will only ensure the safety within your building and on your roof spaces. Thank you.
Thank you, Laura. And thank you to all our speakers. That is everybody, and you've stuck so closely to time. We're actually 2 minutes early, which is terrific because it means we can get plenty of our audience's questions in. And some of them have been coming in already. Please do use the app to put more in, because we've got 20 minutes now to put some of these questions to the panel. I'm going to start with Owen. And many apologies, Owen, if I pronounce your name wrong, but Owen Query from the London Borough of Waltham Forest, who's asked, should roofs with solar panels be subjected to the same tests outlined by Mark? What fire safety tests cover solar panels? I think he asked that question before you spoke, Paul, but I think it is still relevant, and I do want to hear a little bit more about solar PV. So, Mark, I'm going to throw this over to you. We'll answer the question specifically, which is, should roofs with solar panels be subjected to the same fire safety tests you outlined? But could you tell us a little bit more generally your thoughts on making a solar PV roof safe, and what housing providers should be thinking about if they're looking to take that step and install a solar panel system?
Well, I think there are two different situations emerging with regard to solar panels, well, solar roofs in general. One is roof covering materials that are actually solar PV cells themselves. So we're seeing the introduction of a number of new, essentially roof covering products that are in fact solar cells themselves. So the traditional rooftop PV array, where you've got panels on, usually on aluminum frames that are then attached or fixed to the roof, is one situation. But we're now running into a second situation where the roof actually incorporates the cells themselves. When solar cells are used as part of a roof, when they're actually the roof covering material, they are subject to EN 1187, just like anything else would be. They're not going to have much of a problem. As Paul said, the test isn't all that severe, so they'll probably perform relatively well under the standard ENV 1187 criteria. But 1187 doesn't look at what happens when those cells themselves malfunction. We've never had roof systems that actually had active elements, right? That had conductive elements and other things. There are other tests for the solar PV cells themselves, but the test, EN 1187, has really been designed with the assumption, and I want to be clear that this is an assumption, it's not necessarily a validated one, that the conditions that occur when a solar PV array on a metal frame malfunctions will generate conditions that are already replicated or assessed by the test method itself, the EN 1187 test. Now, again, that hasn't been validated, so buyer beware. We have not seen, we've seen a number of rooftop solar fires. Most of them have caused damage to the roof, but usually it's the solar cells themselves that are most damaged and contribute the most to the loss. And the biggest issue with those solar arrays is that it's hard to de-energize them. So many fire services are reluctant to actively engage those fires, which means they can go on for quite a considerable time and spread uncontrolled to whatever arrays they can involve, simply because we don't want to apply water to energized equipment. So I think there are a combination of answers to your question, and I hope I've answered it adequately. If not, please feel free to ask a follow-up.
No, I think that was very clear and very thorough, actually, Mark. But I'll move on to another question. This one from Christian Gonzalez from POW Architects. He's asked us, it's not entirely clear what is being suggested. Should architects specify roof build-ups that meet current building regulations, or should they be specifying roof build-ups that limit or remove the risk of fire entirely? The latter is problematic if testing doesn't provide the necessary assurances. So there's a few things to unpack in that question, but I think what's being asked there is, should we just be talking about compliance, or should we be talking about the removal of these risks? And does testing give us the right information to make that decision? I think it's an architectural question. I'm going to throw it over to Steve and David. How do you approach this in your work? What question are you asking yourselves? Is it just about compliance, or is it about something more than that? And how do you get the assurance?
Well, certainly with a lot of recent jobs, we've been fortunate that clients are very engaged to make sure that we've got all parts of the building fairly robust. So we actually talk early with a variety of people, including the fire safety consultants and engineers, as well as approved building control inspectors. We often have lots of workshops. We do a kind of collective approach where we try to specify and iron out all the issues so that we're completely non-combustible and fire safe, rather than just meeting compliance. I think it's better practice that way. I think you feel as if you're looking at any future proofing of problems, etc. You're working out details of where there's penetrations or inverted roof scenarios, etc., etc. So yeah, we try to do the whole lot with a collective effort.
Thanks,
so that's
Steve.
what I would advise. Try to make it as thorough as possible.
Yeah. Yeah, I think it's always a mistake to only think in terms of compliance, isn't it?
Pete,
I'm gonna
I'd like to just make one quick addition to that. So one of the questions that the questioner asked was, the extent to which we can rely on the tests. Bear in mind that ENV 1187 is only one test that's applied to roofing materials. There are other test methods that address some of the shortcomings Paul identified. We do have tests for assessing the fire performance of roofs exposed to fires below and fires that are caused by exposures from the exterior wall system or exterior edge of the building. So if you're looking for roof performance, don't rely on 1187 alone. It's not going to tell you everything you need to know. And don't rely on the listing certificate or just a label on the product data that says, hey, it's been tested to 1187 and here's the classification. Ask to see the test report. And if the test report provides information that's not really intelligible to you, hire a fire engineer. Get advice.
Yeah, I would agree with that, Mark. We are often asking our fire engineers to make sure that they're looking at all the accreditation. One thing I would also add is that it's difficult at times. If you don't really have the right setup of design team or client, many architects will struggle with this problem. They will, clients or architects might refer to just making it compliant. And in some ways, it's a lot to ask of architects, but the only thing that I can say is you've got to almost work as a team better when you're specifying, and it's easier to do when the architect has more responsibility on a project. The one that I was talking about specifically, we're also principal designer, so we're driving a lot of the thoroughness through the project.
Thanks, Steve, and thank you, Mark, for that contribution. I have a question here from Paul Matthews from Mark McDonald, and he's asking us if anyone's of the opinion that insulation materials of roofs should have the same minimum fire classifications as those found in the UK's building facades above 18 metres, and if so, would that criteria be appropriate for roofs? Obviously, post-Grenfell in the UK, we have a ban on anything combustible pretty much on the external wall of a building if it's above 18 metres. Should the same apply to roofs? Is it that simple? I'll come to you with that, Paul, given that it's an insulation question.
And I'm probably going to give a biased answer, but my answer to that would be absolutely. I think that's something that needs to be looked at. I mean, it's a substantive area of a building, and it was touched on earlier that with modern thermal regulations and a drive towards improved thermal performance, which is absolutely the right thing to do. There's an increased level now of insulation applied to roofs, therefore an increased fire load if you're using combustible materials potentially being applied to the roof. So I don't believe that maybe the guidance is kept up with that, and realizes or recognizes the sheer amount and volume of combustible materials potentially that can be located in that zone. So I certainly think it's something that needs to be considered.
Thank you, Paul. I'm going to come to Laura with a question here from Pete Payton at L&Q. He's asking us what our experience is of dealing with rooftop comms equipment agents on existing buildings regarding their equipment having to be fully considered in the evidence gathering for the building safety case files and reports. So quite a specific question there, Laura, about rooftop comms equipment agents. If you've got experience of that, I'd love to hear about it. But perhaps just third parties who are coming in and making additions, doing maintenance, etc. How are you finding it in terms of their equipment and their processes and how easy it is to work with them? How is that working out for you guys in Sunderland?
Yeah, it's a good question. At the moment, obviously, we are working with all the other people that have a stake within our buildings, not just the comms equipment. We've got other accountable people who have ground floor shops or ground floor restaurants underneath our high risk buildings. And I think it's all about working together and educating them to the risks and the requirements of the Building Safety Act. You know, we are the principal accountable person in a number of these cases, so we are working really closely with them to make sure that they understand what evidence we're trying to gather for our building safety cases. Now, I do feel we're quite fortunate that we have digital twins of our buildings, so it is proving a little bit easier with those. But it is all about that joined up communication. And I would say a lot of it is about educating these people with the equipment so that they understand the approach that we're taking to building safety.
Thank you, Laura.
Difficult.
Sorry, did you? You might have cut out slightly there.
Sorry, I did say it is a difficult task, and I think there's no one shoe fits all for anyone. It is harder with other contractors than others.
Yeah. Thank you, Laura. There's a couple of questions coming about the sort of root cause of the Grenfell Tower fire and the roof at Grenfell. I might actually take that question myself, given it's an area I know a little bit about, having written about it for so long. Obviously, the Grenfell Tower fire is primarily a facade fire, and it's usually understood in that way. The roof was actually relevant, and quite significantly relevant, because there was a architectural crown added to the roof, which was made of the same ACM cladding material which the external wall was made from. And it was when that crown ignited that the rapid lateral spread around the building took place at the top of the building, which was very tragically quite a critical role in the number of fatalities, because people had fled to the top of the building to escape the fire when they couldn't go down the stairs. So you had very, very, very full flats at the top, and that feature took the fire quite quickly to those places where people were. So, you know, Grenfell is obviously, it's a facade fire. People don't think too much of the roof element, but the presence of combustible materials on the roof were highly relevant to what happened at the night at Grenfell Tower. I'll move on to another question, and it's some of these are quite specific. So apologies for putting our panel on the spot, but we've been asked if for an inverted roof, if the insulation is combustible, will it comply with building regulations if it is covered with a minimum of 50 millimeters of gravel or paving slabs? Is there a minimum thickness for the paving slabs? I appreciate this is a very specific question that you probably need to get professional advice on for your project, if it is one that you're working on. But I might throw it over to Paul and just ask in more general terms. Paul, if you can answer that question very specifically, do. But what are the rules around using a combustible material and then covering it with gravel or paving slabs or something like that? Is that an appropriate and legal way of approaching this construction?
As I previously mentioned, you know, in regards to the use of combustible material, if you were on a roof, there's not a huge amount of guidance outside of specific areas. But I think the answer to that is there are requirements within ADB around surface spread of flame across the roof. So the answer to that is that the system should be tested in accordance with 1187 and then classified in accordance with 13501 Part 5 as a system. That's the answer to that. If you want to comply with regulations, then that in the UK, certainly that's the standard that's recognised.
Thank you, Paul. Got another question here from Tim Webb, the BSI, and he's asked what new standard or standards would help the industry with green roofs and, more importantly, with green living walls. This whole process, I hear so much when I go to fire safety events about green walls, and it really does feel like something that the fire safety community has a lot of concern about. I might come to you first with this, Mark, and then I might come to you, Steve and David, to hear a little bit about your experience with green roofs. But specifically the question, Mark, what standard or standards would help with this? But do you want to give us a little some of your thoughts about the issue of green walls and roofs as well?
Sure. I think Tim probably knows this, but we're still in what I would call the pre-normative stage for the development of fire requirements for vegetative roof systems. Been quite a bit of debate within the codes and standards arena globally and in each of the national systems about how to address this. We've recently had some published fire test data from a fire test lab in Europe that's given us a better indication, not a complete picture, but a better indication of what we might be dealing with vegetative wall and roof systems. And to be honest, under certain conditions, these are quite frightening and very challenging fires. I guess the question that we're going to have to come up with is not only what we expect of the roof system when we put vegetative elements on the roof, but we're also going to have to deal with the vegetative elements themselves, which is more an operations and maintenance question than it is a fire exposure question. So the U.S. regulations have already begun to address this in part, and they've addressed it by saying that if you're going to put a vegetative element on a roof or wall, you have to have an operations and maintenance plan, and it must have permanent continuous irrigation. So that starts to present some challenges for us because it adds to water usage. Now, it can be a very efficient water usage by using drip-fed irrigation and other methods, but you've got to get trade-offs in other areas in order to make that work if you're trying to move towards net zero energy, water, and waste. So I've worked on a couple of living building projects which are intended to be net zero in all three areas, and vegetative elements on walls and roofs have certainly been a big part of that. But they're not only being used to we're not only watering those, but we're using them to collect water. So I think we're going to have to see standards not just addressing the potential fire exposure these present, but some fairly robust standards and regulations around how they're situated and maintained. And that has begun to emerge. And I'd say to Tim, if he's interested in talking about this, I'd happily engage in an offline conversation about it, because there are some nascent efforts in other countries that we're aware of at IFE and that we're monitoring.
Thank you, Mark. Steve, do you want to share anything? I know we are running into the closing minutes, but any thoughts on green roofs?
Yeah, just to follow up a little bit. I think one of the problems, particularly with green walls, possibly more so in green roofs, green walls often come with hefty ongoing maintenance charges that clients tend not to like, regardless of what type of client that is. So in some ways, I think there does need to be, new standards, new regulation, perhaps, but also possibly a little bit of lateral thinking in respect to, as I was saying earlier, we're dealing with a project where we've got a lot of attenuation at source. We're trying to find out how to use that attenuated water to help with the irrigation of a small green wall element and so on. So cutting down water usage, yes, you've got to do that, and that more and more planting is going to be a problem. I agree with Mark, O&M manuals, and also, I think when people are dealing with more hefty kind of plantation up on roofs, which is maybe becoming more common now, the roof structure tends to be more robust. And with that, I think there should be, in effect, a kind of new section within the O&M manuals about that roof system, because you'll be joining up a lot of things to do with insulation, water prevention, water usage, and maintenance, ongoing maintenance. So it's a tricky one. I'm not for one to sort of always ask for new regulations, but to keep an eye on that one for sure.
Thank you. Tim, since you've asked, I'll connect you with Mark after the session so you can carry on that conversation. We have 1 minute left. I'm going to throw quite a specific question over to Laura. Just we haven't heard from you for a little while, Laura, but you may have the answer to this. Somebody wants to know whether PAS 79 requires such a stringent assessment for roofs as it does for the other 4 facades on the building. Have you had any experience yet of that at Gen 2?
So no, PAS 79 hasn't taken account of the roofs yet. Obviously, external walls have come into effect under the Fire Safety Act. and that needs to be addressed under the fire risk assessments. However, at Gen 2, we do look at the roofs. We've used the PAS 79 method, but we've obviously adapted it for our own benefit. And what we've got to remember is these documents are released as guidance. They're not always the most current, up to date, because it does take a lot of time to review these, and it can take a number of years. So what my advice to everyone would always be is to look at that building specifically, and if it has got solar panels on the roof, or if it is a living space on the roof, then to account for that in your fire risk assessment. Don't always be stuck to what that PAS 79 questions are asking you. Adapt it to make sure you are fully assessing the risks within that building.
Thank you, Laura. And I'm very sorry to say that we are out of time. I know there's some more questions I didn't get to, but I can't trespass too long on our panel this afternoon. So all that remains for me to do is thank you all very much for attending this session. I hope that you've got a lot out of it. Please do remember that the recording will go up on our website next week, so you can watch it back and you can pass it on to colleagues and share it around. And you should be able to download the slides which our speakers have used via the app that you are using to watch this webcast. But like I say, all that remains for me to say is a huge thank you to everyone for taking their time out to share so generously their thoughts, especially in the Q&A. So I would normally ask you to clap, but it's a webinar, so just please smile at your webcam, and we'll be in touch in the future about future events. So please do keep an eye out for it. So thank you all and take care.
Thank you.
Bye.
Thank you.
Thanks. Bye.